Good. So welcome to the 2016 ICCE, the International Conference on Consumer Electronics that takes place parallel to the Consumer Electronics Show in Las Vegas in the Convention Center. Here with me is Peter Hoddie from Marvell Semiconductors, and he gave the opening keynote speech at our conference this year, and we're delighted to have him not only as our speaker, but he's offered to answer a few questions on camera. So first of all, Peter, welcome and thank you for your talk. I'd like to ask you a little bit more about some of the subjects you talked about during your talk. First of all, you defined for you what Internet of Things, IoT, for consumers means. Could you say a few words about that?
Yeah, I mean, I think what we're seeing happening is that every item in our home, in our cars that's attached to our bodies is getting a digital processor added inside of it and is getting some kind of a radio, whether it's Bluetooth or Wi-Fi, added to it to be able to talk to each other. And this is starting to redefine, the things in our world in the same way 100 years ago electricity started to redefine the things in our world. And so it's a really interesting time to set in place some new paradigms and some new ways of building products.
Good. Now, you explained that a lot of these different things are speaking different languages. They're somehow not directly compatible with each other. And this could be something of a challenge or an opportunity. And there are various standardization efforts taking place at the moment. Could you say a few words about that and whether you think standardization for IoT makes sense? Is it a good thing, or is it just here to make our lives more complicated?
I think ultimately we need standards for IoT. I think that as an industry, a lot of us aren't yet completely sure what IoT is going to mean, and so there's maybe a race to try to standardize things before we understand them. And so, what I was advocating for today is some more engineering first, some more experience first with products, so that we can figure out what the standards should be. So that we can then help grow the industry from there. But there's no lack of consumer interest in Internet of Things devices and connected devices, and there were 500 companies this year at the innovation part of CES showing every connected device you can imagine. So it's not a shortage of ideas, but we need to work on getting those things to talk to each other. It's not about We're not adding network connections to these devices so they can be standalone devices that now talk to the cloud. We're adding that connectivity to them so we can talk to them from other devices, from our phone, and we can configure them the way we want to, just like we have our computers and our mobile devices. So I think that's where we've got to go with standards, is experience first, standardization second.
Now that's an interesting point you raised, because some people might say, why don't we just upload all of the data into the cloud in whatever format it comes into, and then we can translate it in the cloud and pass it back down to whatever it is we want to be controlling or measuring. What is the limitation of that? Well,
I mean, I think there's a lot of them. For some data obviously should go to the cloud, and people are doing that. But if I open my front door in California, right, and I want the lights to come on in part of my house, I don't need a server in Washington, D.C. to make that decision, right? That information can all live inside my house. It'll be faster, it'll be less expensive, and it'll be more secure, because that data is not flying all the way across the country where somebody else can intercept it. So I think that's really important. And so we want to kind of have control at the right point, and the cloud has a role to play in that, but it can't be exclusively where all the data flows. The other thing we have to remember is we go crazy in our lives if the internet goes out for 5 minutes and we can't check Twitter and check our email, right? It's a disaster. And imagine if all the things in your home don't work because the internet's down. And there are still parts of the world, lots of them, where products are defined by their ability to cope with electricity going out for hours at a time during the day. And so we can't build products based on reliability of global internet infrastructure as like a precondition. We've got to build products that are robust enough to work, off the grid, when somebody's on a mountainside, or the power goes out, we've got to be able to think about those things. And the internet isn't always going to be there, but local network connections can be battery powered, for example.
Very good. Now you said one of the things we need to have to get mass adoption of IoT, or that's going to somehow enrich all of these devices we've got out there, is a way of programming them and somehow democratizing it so that it's not just in the hands of a few specialized experts who are perhaps C or C++ programmers. First of all, why should it go into the hands of, if I dare say, amateurs? And is that a good idea? But the second part of the question is, what alternatives are there?
Yeah, I mean, the challenge is that the degree of functionality that people expect is more than any single company can do. There are so many different cloud services that you want to talk to. There's so many devices that you want your light bulbs to talk to when you start to actually think it through, that those companies that make those products can't build in all those connections themselves. They can't. It just doesn't scale, and so we've got to let other people do that. Aggressive startups, scrappy engineers, college students with great ideas, individuals who, today rewire things in their home, like no problem, right? They'll go get out a screwdriver and I used to rewire the phones in my parents' house back when, and we should be able to do those sorts of things if we want to. It's our technology, it's our devices, it's our lives, and we should have that flexibility. But it's also what sparks growth. The PC industry, right, grew because of apps, because anybody who wanted to make apps could do it. And some of those amateur apps were very important for sparking certain segments. Same thing in mobile. Mobile smartphones took off when you could put your own apps on those phones, and it wasn't just the manufacturers and a few select companies putting them there. And so I think IoT is going to benefit from that same openness and that same kind of organic growth and ability for anyone who wants to make the effort to contribute.
Okay, so in lowering the barriers to entry for perhaps non-technical specialists to program their own apps or own scripts, what other options are open to them apart from C?
The thing that we've been advocating is use of scripting languages, and particularly JavaScript, because it's so well known on the internet today, and so well known on the server side because of Node.js. And it's sort of proven itself over the last 20 years as really a practical language to be used in these contexts, portable, performant, and adaptable to different situations. And so part of what I was showing here today is talking about some of the work that my team has done already to use JavaScript in embedded devices as kind of a proof point that, if we look 5 years into the future, which is really what we're talking about in this keynote this morning, that this, if it's possible today, it's going to be very practical as we look down the road.
Well, it sounds like it's time for a commercial break. Peter, could you tell us about some of the work your team is conducting at the moment, particularly with regard to JavaScript, and you mentioned JavaScript, this version 6.
Sure, so we've got a JavaScript engine called XS6, which is really great for embedded devices and mobile apps that we build, and it's all open source, so you can go pull it off of GitHub, just look for XS6 from Kinoma. And it really makes it possible to add scriptability to a huge number of the embedded products that are out there today.
Okay, great. Well, over Christmas I was sitting in front of the television with one of my nieces with a Raspberry Pi, which is a bit like an Arduino, running Scratch, and she was setting up little scripts and making fun things happen on the screen. Does that mean that she soon will, even though she's 9 at the moment, she soon might be able to program Internet of Things devices? Absolutely.
You mentioned Scratch, and 9-year-old. We ran a programming after-school class for a group of girls in near our company. We had 30 girls come in for an hour and a half for 10 weeks, and we taught them programming concepts. And we used Blockly, which is a lot like Scratch. And they were turning on and off lights and reading sensors and doing client-server interactions and building simple user interfaces. And for them, there was no fear. There was no hesitation. They're like, of course we should be able to do this, and of course we want to do this because we want to be able to control all these digital devices that we grew up with, right? It's not something that's new and strange for them. It's just what's always been. So of course they want to do that, and of course they can. It's possible. It's really possible to do these things.
Well, in that case, I'm not looking forward to April Fool's Day this coming year, because I have no idea what she's got in store for me, with lights switching on and off and radios going on and off and all kinds of other tricks. Peter, just before we conclude on this subject, you mentioned right at the beginning of your talk that you were previously deeply involved in the Quicktime development, and when you worked on that, there were two particular aspects that you had to bear in mind, and one of which was how to make it future-proof, and I believe some of it is still being used today, some of that code from, 25 years ago. And the second one is about the importance of user-generated content and providing the tools and providing the means for people to make all of these interesting things happen. Could you just say a few more words about your time there?
Yeah, no, I mean, I was, unbelievably lucky to land at Apple as video was kind of taking off, and got to contribute to that. And as you said, I think some of the really important decisions we made then was recognizing what we didn't know and designing the system to be open enough for us to enhance it down the road and for other people to come in and enhance it, and to realize that content, video. It wasn't just about playing video. Somebody had to make that video, and we could help provide infrastructure to make better tools. And if you look at it, that is, it's a software platform, Quicktime, that let other people build their businesses around it, bring their ideas to it. And that's what helped make it so successful. There were so many video engines at that time, that were good in their own ways. And, we did a nice job, but they did a nice job too. But the fact that we were a platform lots of people could contribute to is what really made it a big deal. And I think that experience is part of what makes me such an advocate for openness in IoT, where we can do a good job, but the best things are going to emerge as more and more people start to bring their ideas to that, and we have enough openness and flexibility that we can adapt to the future rather than being locked into a standard that we designed once.
Very good. Well, Peter Hoddie from Marvell Semiconductor, it just remains for me to thank you very much for giving the opening keynote speech at this 2016 ICCE in Las Vegas. Thank you.
Thank you so much.